Hello and welcome to section 3, in which we will be looking into Python special methods. First, we will be passing arguments into the init initializer method. Then we'll be calling a super on the parent class. After that, we will be looking into represent and string for string representation. Then we'll be defining the API via the _all special method. We'll be passing the command line argument using argparse. And in the end, we'll be looking into exception handling with the try except finally Python block. So in this video, we'll be passing arguments into the _init initializer class method. And we'll be doing that. And we'll be first looking at the most simple way to create class instances. We'll be creating classes with and without an initializer. We'll be creating class methods. We'll be calling those class methods. And then we'll be looking deeper into classes that do not have a _init method. The simplest way to create a class in Python is to simply define it. And the next simple way is to add an init initializer method to the class. So right now we have created two classes, Python class with a _init method. And we use pass to make it legal so we don't get an exception. And the Python class no init, that is basically all empty and has only a pass statement in it. So it looks like they're useless. We can't do anything with them, but we can do one thing with them, and that is we can create instances of those classes. So with parentheses behind them, we instantiate them, and we can see we create two different objects, and that's all we can do right now with the way they are. Classes are typically a combination of data and methods that manipulate that data. So we expect them to have data, also referred to as a state, because different instances of the same class can have different data at a certain time. So they have different state. And so other than data, we also need methods to do something with that data. So a typical way to initialize a class is via its _init method, as we've done here in the Python class. And when we create the class, we then can pass an argument. So this string here is an argument that's being passed into the class. So when we create the Python class, just the name with parentheses, first argument, the string here, gets assigned as an argument to the name variable. And the second item here, items equals none, has a default. So if we don't pass it in, it defaults to none. So what's happening is in the initializer, name gets assigned to the self attribute, to the class instance attribute self.name, and items get saved as self.items. And the self dot is necessary for the methods within the class to be able to access those instance attribute. So in this class, the get name and items, if the name and items that have been passed in wouldn't be saved as self, we wouldn't be able to get to them from any other method within the same class. So self is necessary so we can get to them from within the same class. So this is a typical way to create a class and pass data into it. And let's just run it. So it just runs, there's no error. So now that we know how to pass data into the class during the init initialization creation of the class, we want to be able to get it back out. We want to access the method get name and items to get data back out. So the way to do it is when we create the class, we assign it to a variable. So when we create a class, there's an instance variable being created, and then we can use this instance variable, which I named inst. So we can use an instance variable and use dot notation, and then call get name and items. We can call the method of the class via the instance variable, and here we print it out. So let's see if this works. So we are getting back, this is my name, which is the name we had passed in. And we're also getting back the self.items attribute, which defaulted to none. So this works. This is how it's supposed to work. Now let's add a method to the other class as well, the one that doesn't have an initializer, that has no init, no _init. So let's add the same method, get name and items, and let's return self.name and self.items and see what happens. So in the first attempt, we are passing in the same thing. We're passing in the name, hoping that it will be getting assigned to the self.name instance attribute. So let's run this. It doesn't have the focus. Let's try it again here. So what's happening is we are getting an exception. It says here type error. Python class noInit takes no arguments. So we are trying to pass in an argument and it doesn't have an initializer, so it doesn't want any arguments. So let's try it in a different way. Let's comment this out and run it again. So here we are not passing in anything. And now we get a different exception. It says attribute error. The class noInit has no attribute name. So when we try to return get name and items, it says, well, I don't have that. Even though they're in the class, they sort of don't exist. So it seems like without a double underscore init method, no class can get created. That's what it looks like right now. So let's see if that's really the case. We know that Python is a great language. So even though this case here looked hopeless and impossible, actually it is possible with Python. So what we can do, we can create the instance of this noInit class, save it in an instance variable, and then we can use the instance variable to add an attribute to this class. So we can give it the missing self.name. We can do that here. So when we do instance noInit.name and then give it a string, this then becomes the self.name class attribute that it didn't have. And the same when we do the self instance noInit.items and assign it a list object, then this self items suddenly is part of the class, even though it wasn't there during the definition of the class. And now when we call the same method we tried to call before, when we call that now, it's working. So that's something special about Python. Other languages cannot do that. So you can create a class without an initializer and return attributes of that class that weren't defined in that class. In this video, we passed arguments into the double underscore init initializer class method. First, we created the minimum amount of code to create a class. We understood that classes are meant to hold data and to manipulate that data. We saw how we can use an initializer method to pass data into the class during the class creation. And in the end, we saw that when we have an instance class that doesn't have those attributes, we can add them afterwards. So we can use the instance of a created class that doesn't have an initializer and add those missing attributes, pass them in, give them data, and then call methods that were defined.